Okay, we are live.
We are live.
We are live.
Thank you very much.
Yeah, thank you. Say 2 minutes and then we will start.
Okay.
But in our first
No, I'm fine. I'm fine.
Okay.
Thank
That's
you.
good. I think we should start at the moment. There will be also streaming, and it will be seen on the stream as well for everyone. Dear colleagues, dear our guests, welcome here, and in the streaming channel 2. I especially greet candidate Alsardia and both professors, Dr. András Előd and Dr. Ferenc Sarka, who have been asked to review the debate. Thank you for accepting this role and evaluating the dissertations. And I'm also greeting Dr. László Vas, associate professor who acted as consultant throughout the process. I'm Peter Manduki, I'm the head of the department, and I will be mentoring today's debate. I am pleased that the candidate reaches this point defending his thesis, and I hope it will be satisfying, and at the end of the dispute, he will receive much useful opinion for his PhD thesis. Home defense is an internal forum to help the candidate for his work, therefore much less formal and as a public debate. However, we will only following these steps. The candidate will present his dissertation and introduce their thesis. Following, I will ask the reviewers to tell about their observations. And the end, I will ask to honor the reviewers to inform us whether they support the debate to go to public, as well as whether the dissertations complies with the BMA doctoral obligations. Following that, the candidate will have the opportunity to reflect on those. After that, we will have the opportunity to make the discussions as well here in the room and as well in the streaming lines as well. Okay, has anybody any questions about it? If no, I kindly ask Mr. Talal Alsardia to make his presentation in 25 minutes approximately.
Thank you, dear Chairman. Thank you for this introduction. Dear reviewers, dear guests, and people in the stream, thank you for this opportunity that I share with you my research related to the study of loosening of field goals, both preload variation during repeated loosening cycle under the supervision of Dr. László Vas. In this presentation, I will give introduction about the topic, what's the importance of this topic, the goal, the methodology and the experimental procedure, and the achieved result, thesis point, conclusion, and list of requirements and publications. The type of the joint that we are speaking is one type of the threaded fastener, one which is consists of bolt, washers, and 2 or more members, and mating nut. We have preload generation. The preload is supposed to be sufficient to keep the member together in contact. The estimation of this preload is based on the bolt material yield strength, and we generate it using tightening process. Some of the tightening methods that are used to generate preload is torque control, rotation angle control, and bolt elongation control, along with, and finally, the direct control. Among them, torque control is the most common one used because it's easy to facilitate. Tightening torque determination, there is a theoretical part for determining the climbing force. We have this Motish equation and the ISO 16047, where the torque is related to the preload as a function of the geometrical and frictional parameter of the joint. Another approach is experimental, which is based on the nut factor, where the torque is related to the preload as a function of calculated constant based on experiment, which is nut factor or nut coefficient. What's happening during the tightening that the input torque, up to 20% of the input torque is generating the preload. The remaining is consumed to overcome the friction under the rotating head and between the mating thread. Problem during tightening process that the preload range is uncertain. Another problem during the service time, what is happening to the tighten bolt that is facing static load or dynamic load. The dynamic load could be periodical in time and it could be stochastic in time. The stochastic in time is a typical example in the application in the vehicle industry. Another issue that the loosening mechanism type is uncertain. The main indication that we can judge the looseness of the bolt is the clamping force degradation. What is self-loosening? Self-loosening is the undesired loss of the preload that is used to keep the component in contact during service time. As we can see here in the graph, how the degradation of the clamping force. This phenomenon can cause problems like nose because of loose part, instability of loose structure, and complete failure. And some cases that increase the maintenance cost, we need to install some indicator and it increase the maintenance cost. And in some cases, it can cause accident. We have two types of loosening based on the mechanism, rotational and non-rotational loosening. The rotational loosening, under excitation of external load, there is a relative motion between the nut and the bolt axis in the untightening direction. While for the non-rotational, there is no relative rotation. The loosening can happen from the gasket relief, joint relief, different thermal expansion coefficient, and from stress relaxation, sometimes also stress redistribution. What's the importance of this research? As we can see here in the diagram, analysis for bolt failure from the literature between 2016 and 2021, and we can see the dominant one is the bolt looseness with a percentage up to 48%. As an example of what's happening from this loosening, we can see here in UK in 2007, the train derailed from the rail, and the main cause that there is a failure on the switch of the rail. There is 3 bolts missing in here and 2 bolts missing in here, and this is a mark of the dynamic movement of the bracket. And we can see here is the nut. So this is an example of what's happening from loose bolt. Another example in 2018 in USA, National Transport Safety Board published a report. The damage cost $4 million because of over tightening 3 bolts for engine head. In 2022, also another accident happened, that similar cost of accident from loose bolt. Existing practice in the industry suggests that after dismantling the joint, use another bolt and washer and nut. And this is for safety reasons. What's happening in the reality that dismantled fastener are reused because of fastener availability, ecological or economical, and sometimes poor maintenance procedure. As an example of what happened using an old fastener, in 2010 in UK, a transport research laboratory published a report saying that around 11,000 cases of loose wheel nuts. Among them, there are 400 wheel detachment. And we can see here what's wheel detachment. That the wheel completely loose from the vehicle and can hit another vehicle. This is one accident type. 134 accident, 27 injuries, and up to 7 fatal accidents each year. So, the economic cost, the downtime, and the safety hazard associated with the bolt-related issues underscore the importance of addressing this issue systematically. The goal of the research. For a selected parameter, the goal was to build up a measurement method that gives us the ability to study the variation of the clamping force in a bolted joint, initially achieve preload, the preload variation during repeated tightening, and the effect of various parameters for different tightening conditions. Moreover, we wanted to study the friction between the mating threads and under the nut, calculating the nut factor, understanding the deformation that happened for the thread and under the head. Also to provide a practical recommendation for designing or maintenance or operation in the industry where the tightening and loosening is common. The methodology and experimental procedure. Here we see the study voltage joint. We use two types of torque control generating the preload. We use the torque along with strain gauge. This is the experimental setup. Measuring the clamping force, the preload variation, the repeated tightening as well on the same bolt, different tightening condition, also calculating the nut factor and the variation of the friction at given places. For the preload part measurement, the experimental factor was size, surface finish, and lubrication. We have three sizes, M6 and M8 and M10. For each one, there is a corresponding tightening torque used for each size. Surface finish, we have black and zinc coated, and lubrication condition as received from the factory as we open from the box and we use it. A dry one after cleaning. Then we have solid molybdenum powder and oil. The tightening cycle, we tighten the bolt, we measure the preload, then we lose it. This is one cycle. And this is repeated for the same bolt 20 times. This is the measurement flow chart. We add the lubrication after we clean for the three cases here. The dry is clean. MOS, we clean the bolt, then we apply solid molybdenum powder and oil and before the first tightening. For the friction measurement, this is the layout for the studded joint. Here we see in this part we added the thrust bearing so we can minimize or eliminate the torque underhead, and what's remaining is that between the mating thread. Compare it with another joint with the same length, so we can, between both of them, we can know what's the friction under the nut. So we use M8 with a 20 Newton meter tightening torque, zinc coated as is, 20 new bolts for each case, and 40 repetition for each bolt. The result. Here we can see in this graph lubrication cases on the x-axis and the preload in the y-axis. We have three sizes, M6 in the blue, M8 in the red, M10 in black. This is the black bolt, this is the zinc bolt. And here we can see what's important, that even for example for M6, it's the same tightening torque, and we can see here that there is a variation in the friction that affects the generated preload. So for the same bolt, even we are using the same tightening torque, it's not the same result at the first tightening. And also there is a difference between the zinc and the black. Among them, the dry, it was lowest in all cases. Here we can see, for as is M8, the case was different or higher. This could be related that the black bolt, when it comes from the factory, they have protection layer. It could be oil, grease, whatever the factory is using. So it could be that in this case, the lubrication or the grease is different. During the repeated tightening, here we can see in the x-axis also the cycle, in the y-axis is the preload, the top part is for the black bolt, the lower part is for the zinc bolt. What's interesting that here we can see the similarity, for example, for the zinc in the as-is and the dry. They are having similar trend, black bolt between the oiled and as-is. We have like too slow around the 10 tightening cycle decreasing, and then somehow the variation is more or less stabilized. Also, here we can see that the dry one is all lowest. Adding lubrication enhance the performance. For more clarification, here we can see, let's consider this equation as a variation. We use the first tightening cycle as a reference one, and then we compare it during repeated tightening. Manufacturer said, okay, at the first time tighten with 10 Newton meter, but there is no suggestion after that. If you use it again, what will happen? So we assume that the first point is the reference one, and we compare it with the remaining. In this part, in each figure, 3 sizes for the same lubrication case. Here it's interesting what we see here for the black oil and for the zinc oil. How 3 different sizes, the variation is having similar trend. And this side, same bolt, 4 lubrication condition together. And what is interesting, we can see here, like we reach 50% decrease for the zinc. Also, we can see it clear here that similarity between the acids and the dry. Here we reach 40% decrease, here 30% decrease. And also in the black, we can see the similarity in the oil and acids in 2 cases. For the net factor calculation, the net factor is measurement-based factor. So it's recommended when you have an application and you know what's the designing criteria, you can design your experiment, and then you can know what's the range of the preload that you want, how much the tightening torque that you need, with a margin of confidence, because it's give a range. Here, in the box plot, we calculated the net factor, torque divided by measured preload multiplied by the nominal diameter of the bolt, and we accumulated the mean for each point, and here is the representation for the 20 point. We can see from the range that in the dry, for the black and the zinc, the range is high, so the scattering is high. So it's not good if you want to tighten a bolt to clean it, and then you tighten it. So you get a wide range of the preload. Similar for the zinc as is, we see the same case. Adding lubrication, we can see here the oil for the 3 sizes, along with the black as is. They are having lowest part. Lubrication is enhancing, but we can compare between 2 lubrication that the solid molybdenum have higher scatter. Still the range is low, but higher scatter than the oil. Here we move to the friction measurement part. And this graph we see in the red one without using with the bearing, so no torque for the underhead. In the black one, there is a torque underhead, so complete joint, and we use both of them using the theoretical equation to calculate the threads, the friction coefficient. So here it's the friction coefficient underhead, and here the friction coefficient between the mating thread. And it's interesting how they are increasing in here until reaching the 10th cycle for the underhead. In the 5th cycle increasing, and then start to decrease. After the 10th cycle, they are 1 increased and 1 decreasing. This could be related to how stabilized after the 10th tightening cycle. To have a better idea about this, in this we made a photo about the thread, engaged thread. So here is the first engaged thread until the 4th one. 50 magnification using the optical device. From A till H, it's stayed for from 0 tightening before tightening until reaching the 35. Each graph is 5 steps of tightening. We can see how the profile deformation propagates from the first thread, moving until we find here until during the 35 cycle that the 4 engaged threads are plastically deformed. Thesis point. Thesis point 1. I build a measurement method to check the tightening torque clamping force relationship in a bolted joint. Measured data showed that identical tightening torque, successive tightening and release of a bolted length leads to a decrease of a clamping force by 50%. The magnitude of the decrease depends on the surface state and the lubrication. For the second thesis point, measured data showed that the clamping force variation is achieved during 5 to the 10 tightening cycle, and then reaches a constant state independent of the study surface state and bolt size. Thesis number 3, I made a statistical analysis of the measured data to show the effect of the parameter on the buildup of clamping force in a bolted link, independently of the studied bolt size and the bolt coating type. The lubrication has the biggest effect on the clamping force buildup. Thesis number 4, from the measurement nut factor have been computed for various bolt size and lubrication type. This number can be generally used for bolt tightening computation for either the tightening torque or for the clamping force estimation. Thesis number 5, I built up a measurement method to study separately the friction under the bolt head and on the thread. From the measurement, I have shown that the stabilization of the clamping force after the 10 tightening cycle is due to the opposite variation. Of the friction coefficient on the thread and under the bolt head surface. The thread friction increase while the underhead friction decrease. Thesis number 6, clamping force measurements show that the computed friction coefficient changed during repeated tightening of a bolted link. I have shown that the thread friction coefficient variation after the 10 tightening cycles attributed to the plastic deformation of the thread shape. Conclusion, based on the experimental investigation, I made like 9,600 measurements. We defined the range of the generated preload during the tightening process under different conditions. We computed the nut factor for multiple cases. The generated preload during repeated tightening is influenced by a combination of the surface state and the thread geometrical deformation. The contact state is between the mating threads and under the turning head. The contact state is more dominant than the geometrical deformation. Here is the list of requirements for the PhD, and also here is the list of publication. In the publication, I published 2 impact factor papers, Q1, Q2, and Q3. And thank you for your attention. Floor is yours for questions.
Thank you for your presentation, Mr. Alsardia. It was very grateful. I would like to show you the last but one slide, one again, because it's very impressive. One more. No, it's not this one. So it shows that you have made many publications and many requirements.
Publications.
As well. Thank you very much. It's very
Thank you.
To see. After it, firstly, I will ask kindly Professor Dr. András Előd to describe his review, to say some words about it. It's not necessary to say by word, but the most important things I would like to.
Thank you very much. Dear Mr. Chairman, dear colleagues, dear guests, and dear candidate. First of all, thank you very much for your confidence and the possibility to give me this dissertation. In short and consciously, it's a smart, not too complicated, but well executed dissertation with industrial utility. So, the topic of the research is forever relevant because buildings based on the principle of friction always work according to the environmental condition. The objectives are well formulated. The experiments, taking into account the modest local possibilities, were well planned, and the candidate carefully carried out and evaluated them. The results obtained from the experiments are good and instructive, and at the same time they are also suited for industrial use. The appearance and formatting of the thesis is careful. The figures are well developed and informative. And the editing of the thesis meets the BMA's requirements for PhD thesis in all respects. After the general introduction and objectives, the chapter challenges and failure modes explains the importance of the research work. We could see on the slide 10 and a very interesting figure, and practically this figure could you explain the essential of your work. This chapter and the presentation of the objective is very nice and very well written. It is a very well written part of the dissertation. The processing of the literature is good and proportionate. The presentation of the measurement and the measuring devices is well detailed. The description of the measurements and their results is also detailed, meeting the requirement that anyone can repeat them at any time. It is a very important requirement for the PhD work, and I was really very happy. Everything is really well detailed in your work. So, however, a list of nominations is missing from the beginning on the thesis. It is to replace. There are also some data tables which should be transferred from the thesis to the appendix, in my opinion. In connection with the investigations of the development of the preload, I asked in my review how many balls did you investigate in parallel in this case. I saw you investigated 20 screws parallelly, okay, but I have some remarks concerning the figures and the results. In my opinion, for the black screws, the oil lubrication almost returned the results obtained with the as manufactured as is condition, because the oil was squeezed out of the contact surfaces during the first tightening. I suppose it. The uniform reduction of the preload on the cleaned, dried surfaces indicates a continuous and uniformly plastic deformation of the contact surfaces. I think the photos at the end of your dissertation can confirm this statement. The molybdenum disulfide integrates into the surface roughness and provides a uniform reload during repeated tightening. And finally, concerning the zinc coating, it is vitally known that zinc-coated surfaces are not compatible with the lubricants used for steels. I would be worthwhile to compare these conclusions with the conclusions drawn after the results of done tests. In your dissertation, this done test results is shown on the 81 side. You can compare, not in this moment, but after try to compare the results. The statistical evaluation of the measurement results is an interesting and valuable work, but the ANOVA analysis would sometimes require more explanation, at least for me. For example, relation to figures 4, 6, 4, 7, 4, 8. I have some comments also on this. The tables 4, 4, 3, 4, 4, 4, 4 5 recommend. I recommend the tables 4, 4, 3, 4, 4, 4, 5, transferring also to the appendix because they are data tables. See? Concerning the figures 4, 6, 4, 7, 4, 8, what do you want to present? An explanation of the figure is missing. Figures on the figures 4, 9, 4, 10, 4, 11. What do the horizontal and vertical axis mean? Regarding the 7 multiple thesis with the 3-way mixed ANOVA, page 70. Where does it come from? What is the explanation? The following statement that I found in your dissertation. The friction coefficient of the black screw is equal to the friction coefficient of zinc-coated screw. Is it an assumption or a result? Because I think it is not really true. The same, you wrote that the friction coefficient S in, as manufactured, is equal with the friction coefficient dry, that means clear surface, and equal with the friction coefficient which friction coefficient between steel nut and molybdenum disulfide fabricated screw. I think, and at the end, those are equal with the friction coefficient between oiled surface and steel surface. If they are assumption, in this case you have to precise the basis, the basic literature, or I don't know from who could you find these equations? Or regarding the post-hoc study for a straightforward two-way comparison to understand the overall bolting performance, The essence of the method can only be understood on the page 78, not before. That means after the results, with the help of 413 figures 413. The postdoc study is good and interesting in its entirety, but a short explanation is needed before. The analysis of the nut factor is also an interesting and valuable work that I would also put the data table 415 in the appendix. And the last chapter, the triviological part of the research work is good, and it has been correctly documented. So, let me give you my opinion about the new scientific results, about the thesis. In my opinion, the thesis 1 and thesis, the first thesis and the second thesis are related. So I recommend combining them. Third thesis is okay. Fourth thesis, in my opinion, is not a thesis worthy. It is not a new scientific result, only a statement, and only true for the material and size pairings examined in the frame of the presented work. Fifth thesis, okay. Sixth thesis, okay. That means you will have fourth real thesis containing real new scientific results, and it must be enough during the defense. Finally, I would like to declare that I was concluded that the presented work is the candidate's own work, and the results are his own results, which in the form of the formulated thesis can be considered as new scientific result. After making the necessary corrections, I recommend the dissertation for submission and public defense. And I wrote a small and detailed list of errors, easy to make the correction. They are only mistakes, not really errors. So, thank you very much.
Thank you very much for your review. Thank you. Second, I will ask Mr. Dr. Ferenc Sarka to describe his review.
Thank you.
Thank you very much.
Can I stay here?
Of course, you can stay.
Okay. Thank you very much. So, first, about the topic selection. The choice of a topic for dissertation is interesting and timely from several points of view. On one hand, because both the joints play an important role in all aspects of life, understanding their behavior is important not only for researchers, but also for practicing engineers. On the other hand, in many cases, dozens of human lives depend on their compliance. The structure of the dissertation. The dissertation summarized the candidate's work in 120 typed pages, which 99 pages contain the scientific work. The other pages are given by various lists. The dissertation is divided into 6 main chapters. In the first chapter, the candidate clearly described the topic selected for research, its significance, and the methods to be used. Second chapter deals with the literature on water joint. In this chapter, the literature review made it was carried out by the candidate with sufficient thoroughness. This is supported by the number of the literature used, 134. I'm missing a short summary or a conclusion at the end of the chapter. In the third chapter, the candidate describes some methods suitable for measuring the compressive force created by the water joints. In the fourth chapter, the candidate presents the results of his very large number of measurements, almost 10,000, and then draws conclusion based on which he formulates his thesis. The parameters of the performed measurements are summarized in a table, which enables a very concise description. It would have been more fortunate to highlight some of more important values in the text section, thereby helping the reader. The fifth chapter is very short, only 1 page. Unfortunately, he writes little, only 1 sentence about the possibility of further continuation of the research. I'm sure there are still many open questions. The 6th chapter summarizes the achieved scientific results and thesis. Towards the end of the dissertation, it is clear from the text that the candidate feels that the work is already too long and he is trying to shorten it. Perhaps many large tables or measurement results can be transferred into an appendix, thus shortening the page number of the dissertation. All in all, the dissertation presents a series of high-quality, carefully performed experiments that gives new scientific results. About the new scientific result. The candidate summarized the new scientific results in 6 theses. In my view, thesis 1 and 2 present related results, both dealing with the change in the compressive force created by the water connection. I recommend merging and clarifying these 2 theses. For example, which thread type, which material quality, which coating, the direction of change of the factors, in which direction changes the strength of the joint, and so on. The thesis might provide the exact new scientific result even without the detailed knowledge of the dissertation. So I see a similar situation in the case of the third and fourth thesis. It identifies the parameters of affecting the clamping force created by the threaded connection, gives the effect. The condition should be clarified here and merge them together. I would not change the fifth thesis. The condition of the measurement should be better presented in the dissertation. And finally, the sixth thesis, please clarify it, how the coefficient of friction changes and which coefficient of friction between the threads or under the head, under the nut, what kind of thread, what kind of material, and so on. For the thesis, the candidate marked the publication that are related to the given thesis, but they are not indicated in the bibliography or anywhere else in the dissertation, only in the thesis booklet. About the language of the dissertation. Basically, there is no problem with the wording, followability, and comprehensibility. There are errors that need to be corrected. If we name something at the beginning of the dissertation, then we should not call it another similar name in the later section, as received, as it is, as is, and so on. And with the nut factor and the nut coefficient, you have to use the same through the whole dissertation. The use of the possessive structure is completely optional. In English, the apostrophes can only be used for living person or inanimate things and of the personality, ships, countries, ministries, pets, and so on. In all other cases, we have to use the of structure. I mark them all in the manuscript. And finally, the evaluation. It can be clearly stated that the dissertation is the candidate's own work. It consists of authentic and relevant information. The presented results are new scientific results. the dissertation can be submitted for public defense if the errors listed and discussed personally with the candidate have been corrected. This is the end. Thank you very much.
Thank you very much. Thank you very much. May I have a question? As well, do you support it to go to the maybe public debate?
Of
Maybe
course.
this- Thank you very much. Thank you very much for your answer. So I give that verse just to Talal, just answer for this
Okay, sir.
evaluations.
So, first of all, dear Ivan, thank you for your time and your effort for evaluating and carefully reading the thesis. Your comments are valuable and instructive to help to improve the thesis. For the first question that you wanted to ask, if the preload of the blackboard as not outlier, I showed it in the previously. Yes. And how many volts is already mentioned. For the figure, for the explanation, this figure is already explained in the text, so it will be redundant to repeat it again. So for the three-way mixed ANOVA, to compare the mean of the group as between subject factor, here we see the black and the zinc, and lubrication condition for, this is the first group, second group, for condition lubrication, and within the subject factor, which is the repeated measure, from 1 until 20. Previously in the text, they are grouped as one case for the black as is. So the box plot is the same, but here, for the model of the ANOVA, it's grouped by cycle. So it's another representation for the box plot, which is already in the text. And this is just to help to complete the three-way mixed ANOVA, because we want to measure the normality. So if we consider another type of the ANOVA, it will give different option for the normality. So this model can be give normality assumption, because I am comparing cycle by cycle, the two type and within the repeated measure. This is why this representation for the model. So these data are already explained. Is it a clear answer? Or? So for the horizontal and the vertical axis, this is the plot for the QQ plot. So the horizontal axis is the model, ANOVA model, and the y-axis is the residual of this model for the comparison of normality for each cycle. These assumptions, previously I submitted a paper to the Psychology International Journal, and they returned to me, okay, you explained your data, it's just an explanation. What's the evidence that you are saying there is a difference between the mean of the preload for the zinc and for the black? So to build an argument that, okay, I want to validate my result in a statistical way, that I say at a confident level that there is a difference. It's an assumption to build an argument for the explained point before, that I said, okay, there is a difference, there is similarity. So what's the statistical evidence for that? So this is just to compare the mean between of them. So I said at the beginning they are equal, and then this is the null hypothesis, but finally I received, okay, they are not equal. So this is only assumption to build up the argument for the statistical analysis. Related, you mentioned about the assumption. The ANOVA is used to compare mean between groups. It cannot give you what's the best performance and what's the lowest performance. So just the ANOVA say, okay, there's a difference between this mean and this mean. The post-hoc analysis, it was used to define which is relevant, which is good, and which is bad, which is highest, which is low. And finally, related to the thesis, I think two of the reviewers agreed that thesis 1 and 2 are related and for merging, so it will be merged, both of them, combining. And related to the thesis 4, it's also, I received another comment that it should be merged with the number 3. So I completely agree with your comment, and thank you very much for this comment. I hope I answered the question. Dear sir, thank you also for your comment, for your time, for asking me to show me in person where was my grammar mistake and what is missing in the thesis. I really appreciate the time, and I appreciate the careful reading for the thesis. So some of the comments, it will be done in the future, but not in the meantime. I couldn't make it. So the summary of the conclusion for the literature review will be added. Inclusion of other measurement also mentioned in the text already. Clarification of the tightening torque. At a sentence will be clarified the tightening torque and indicated in the table because it was confusing, not straightforward to see it. The chapter 5 will be expansion, including the possibility of the future work and transferring graph table. I received this comment from both of you reviewers, so it will be done. And for the clarification of the thesis and merging, so 6 and 7 here, merging thesis 1 and thesis 4, this will be happening along with the clarification for each thesis point to stand alone that you can understand without reading the thesis. Inconsistency in the terminology and the grammar error, also they will be corrected. Also the inclusion of the recommendation and acknowledgement, they will be added along with the nomination of the nomenclature for the thesis. So thank you very much for your time, for your evaluation. I really appreciate it. It will sharpen the work and it will enhance the quality of the thesis. Thank you.
I'm glad you asked you, do you accept the answers, both of you?
Yes. Yeah.
Okay, thank you very much.
Yes.
Then thank you. I'm opening the discussions. If anybody has any question or anything else that you want to say, then it is done. Mr. Mr. please.
So I think we can be great pleasure for us to have again a dissertation discussion of the department, and especially the subject of the dissertation belongs to our department, although it's voltage joints are very old machine elements, but however they are even today practiced, and we know that from literature and from engineering practice that problems, questions arises all the day concerning with voltage joints. That's why it's a very good choice to deal with this problem. So, some introductory remark. If we consider the title of the thesis, this is wheel bonds, and wheel is not mentioned as a word in the dissertation. So I think it should be considered whether the change of the title or something they use the treated problem to wheels. As only a remark and only an advice, because I am not an official evaluator.
Thank you, sir, for this.
So you can consider this question. So, concerning the work, it's basically an experimental one, and that is a great value of it, because the best dissertations are of experimental one, and theoretical conclusions are to draw from experimental results. That's why it's all very good. Concerning the test rig, it's not very clear some parameters of the test rig, so I should propose to give us the real engineering drawings on the test device. This is the figure 3.10 and 3.6. One, the 10 is for friction coefficient. There's the 6 is the general purposes. But for example, it's not to see how is fixed the melted material against rotation. If the relative rotation can be happen under the head or under the nut, how it is treated this question in the structure. And the other which belongs to here, that you are writing that special washers are applied. What does it mean special? Why it is special? You must not answer that. I advise only to consider this problem, this question. Not treat it further the matting surface degradation during the repeated cycling. It's not an easy question, but at least a mention should be added to clarify that you consider this question and you think it solved in such and such or another way. Concerning the washer, in the general test arrangement, there is drawn washers under the nut and under the bolt head. In spite of that, in the friction measures, there is no washer under the nut. It can be good so, but what is the reason for the difference? You can consider that and give some response. So, concerning some formulations, you are writing, for example, on the 15th page, the surface treatment of the bolt, but the surface treatment of the bolt is not everything, it is a thread. It often happens that you are writing surface treatment of the bolt or surface treatment of the thread. But it's interesting, the surface treatment of the thread. And is similarly on the 14th page, it's wrote that uncertainty, it is a question as a goal to determine uncertainty of the distribution of the ground. But I didn't see some activity for that. I think only the distribution of the ground is to determine, not the distribution, the uncertainty of the distribution. So, concerning the statistical evaluation in the third chapters, you are speaking on big R software, Anovates, etc. And some parameters appear, for example, MEP, mean evaluation plot or what, or S over N signal to noise relation, but it doesn't explain what is it, how to interpret in that question. That's why I think that all chapters of the statistical analysis should be reconsidered and some things are to clarify. Concerning the thesis, I think that this thesis booklet is a correct summarization of the dissertation. The first, second, these are okay. In the third, I think that the figure 5th and 6th can't be understood because there comes these parameters mentioned previously, which are not clear what does it mean. Concerning the knot coefficient, is sometimes called as knot coefficient, sometimes called the knot factor, even knot coefficient factor is sometimes. I don't think whether there are different phenomena or is the same, only the name is different. But it should be the same in each case for the better understanding. Because the lecturer can have problems whether it is the same or it is something other. So, on the fourth thesis, the figure is not to understand. It should be explained as it is explained on the figure 4.2 in the big dissertation. These are the box representation, but the thesis booklet should be understood in itself. So it should be explained even in the booklet. The thesis 6, you are speaking about thread shape, and the figure 9 is rodent annular underhead surface. So it is not a, it is a discrepancy between the figure description and in the text. You can check it. I don't have here the text, but there is a difference. And concerning the figure 10, to this thesis, I consider that it's difficult to see something. Probably it could be magnified sometimes, something, or so, or find a solution for that, but because I think it is not very understand. One can't understand well. Thank you very much.
Thank you very much. Thank you.
Thank you very much for your opinion. Other opinions?
Thank you very much.
Maybe I can have a
Supervisor.
small remark. Dear Chairman, dear reviewers, dear guests, I'd like to sum up a bit all thing. So we are working together with colleague Talal since 6
6 years.
At least 6 years. And first of all, he's a very kind person. Not only a very kind person, but very diligent person also. And he has got the rare ability, which is also very timely in students, to be able to work alone. I just give direction, we discuss about the direction, and then he is able to follow the path designed. He is able to solve the problems, and whenever the problem is too big, then we solve it together. So it is a pleasure to work in by this way. I know there are other students asking every day, is it good? But he is not of that kind. Okay, so quite individual and hard-working person. It is also known that he is not a quick worker, but he is very careful with the details. So even if he is not really quick in his work, once the work is done, every detail fits, and the structure is logic, and the structure is really well built. So it was a big pleasure to work with him till this point. And I'm glad that the reviewers have similar opinion of some notes. For sure. Thank you very much.
Thank you very much for your positive opinion as well. Any other questions? Any other opinion? Perhaps somewhere in the stream, if anybody has any questions, please tell it.
We don't have the
Say it, you.
supervisors. The questions over there we can see on the.
But perhaps if somebody says it, then I will give them the word. Okay, but if it is not, just I give just some seconds. Make it over. If not, I will summarize the key finding and some defenses for this home defense. Also, I think the topic was relevant, as that was a common opinion of every colleague. All scientific results are novel with the opinion of the reviewer colleagues. The candidate presented his own results, it is also good, and the findings are based on the candidate's publication. That was we heard it about it. Does everybody has a feeling on accord, or does everybody have a different opinion about it or objection about it? If not, I will rewrite it in the papers, and I will send these papers following to the doctoral people. And finally, I will thank you for your thesis and for your presentation, and also for the reviewers as well, and for the colleagues. And I thank you for your attention, and I close this session for today. Thank you very much.
Maybe I have some.
Yeah, of course you have. Sorry.
Yeah, thank you, sir. First of all, I am thankful to this country and represented by Stipendium Hungaricum that gave me the opportunity to do my master and to do my PhD here. And I am very thankful for Dr. Laszlo Lovash for his support. Without his guidance, this work will not be done. I am very thankful how he dealt and how it was manageable. It was great pleasure to have this collaboration to find this thesis. Also, I am thankful for my friends for the support. Thankful for Ms. Gabriela Fulla for her support during the work and the thesis. And thankful for the friends who is behind, family who is seeing for their support. And thank you for your time and giving me this chance to present my work to you. Thank you very much. And there is some sweet, I know that it's supposed to be in the public, but I don't know if I will have the opportunity to do it in person. So there is some kind of Jordanian sweet, if you so please. أم موفق متابع مبروك أم موفق